Okay, so this question, they're giving us this big table, and they've got year, number, and power, and we can see that this curve is going up like this. So obviously it's not linear. Luckily for us, they've given us a transform. So it says log10 transform can be applied to the variable to linearize the data. So basically, you need to stick all that data in your calculator, like so. So list 1 is going to be this, and then list 2 is your megawatts. And then what you've got to do is you click here and you start typing here log list 2. You might be able to pull down from a menu the word log, but you can just type the word log. You want to log list 2. Okay, so we're doing a log transform on that. So then what you've got to make sure you're doing on your calculator is, let's just write ourselves down here. This is list 1, this is list 2, but so list 3 equals log of list 2, which is what we want, right? So if you log all that, let's just delete that there. Let's get rid of some of that. You can see that we've got to make sure that we put the X is the years, and we can see that it's the years when we're looking at our graph over here. There's our years. That is our X list 1, and then the Y is the log list, because we said we wanted the log of it, right? So that is why we've got to choose list 3 in our options, and then you just press the number here, and we've got some lovely numbers to put into our calculation. So there's our equation, y equals a plus bx, and so this is the a here, and a is 4.286911. Well, look, we've got to do 4 significant figures, so we've got to chop that off. So 4 is a significant figure, 286, so 4.286. We've got to, if we chop that off, we see we've got a 9, so we've got to make this into 4.287. Yes, because we're rounded. All right. And then when we're looking at that equation, we've got to find where the b is. So the b is this number, and we've got to go 4 significant figures again. Now the zeros at the beginning are not significant figures, so not significant figure, not significant. So the first significant figure is the 9, so 9901. We cut off there. So we've got 9901 as our 4 significant figures, and then you can see it's got a 7 after that line. So just the first 7, the second 7 doesn't mean anything. It's very tiny writing, I know. So you've got to write in 0.0990, and the 1 has to go up because the 7's next to it. So 2, and that's actually all we need to be doing for that question. So it's just to make sure that you got the 4 significant figures, which was written here, knowing what significant figures means. So whenever you have a number, just to remind you, if you have a number like 0.03500200, then that has 4 significant figures, because the only ones that count, these 4 are okay. The 0 in the middle is okay, but any zeros to the right that don't have any numbers afterwards, or any zeros to the left, they don't matter. So that number I just wrote there is 4 significant figures. Now it says use the equation from part A to predict the electrical power in megawatts, that's megawatts, expected to be generated by the wind in 2020. Well, the equation we got from the previous thing was this had to be 4.287, and this was 0.09902, and so times the year number. Oh, wrong thing there. Let's get the highlighter, so times the year number. Now, from the previous thing, if you actually go back to what it said, I'm not going to show you again because I think it's pretty straightforward. So 2001 was year 1, and 2012 was year 12, and we're talking about 2020. So 2020 would be year 20. So you're just going to put 4.287 And remember, this is log of power. Don't forget, if we just say log, we don't have to say log 10. We just assume it's log 10 unless we say otherwise. Times 20. That gives us, if you put that all into your calculator, you'll get 6.2674, which I did into my calculator. There. Oh, sorry, should delete that stuff. And then you can see we got 6.2674. Now, but that's log. So we've got to take both sides of the equation to the power 10. So if we take both sides of the equation to the power 10, that cancels out the log. So you end up with power equals 10 to the power 6.2674, which is what I've done up here. And I got this number here. So we've just got to remember it also says to round to the nearest 1,000 megawatts. So if we look at that number, that is 1850972. Let's not worry about the decimals. Nearest 1,000, well, the thousands column starts there, right? Because that's the ones, the tens, the hundreds, is the thousands. So we look over here, we ignore those guys, and it shows us that we got to write 185, and the 0 becomes 1, and then 0, 0, 0, right? So it's 1851000 megawatts. Don't forget to put your units.